from Idaho, I strive to provide interesting videos about motorcycles, fabrication, welding, electronics, machining, and general creativity. I hope you enjoy. Merry Christmas from Idaho. Hot coffee is the best on a cold day. We're about 40 degrees outside, about 50 degrees inside. And I want to say I blame this video on Super Fast Matt. Super Fast Matt is a YouTube contributor. And to tell the truth, until recently he wasn't all that fast. But he does have a good engineering, fabrication, and folly YouTube channel. And I watch him pretty regularly. And the reason I'm blaming this video on him is because he produced a video that says it's time for you to have a 3D printer in your shop. That and one of my local machinist friends has been doing 3D printing for a while, and he keeps bringing these cool things to our machinists meeting every month of stuff that he's made, and he'll make one for everybody in the group. And so 3D printing has kind of been on my mind. I was first introduced to it in about 1992 when Hewlett-Packard, the company I worked for, had a fabrication shop for doing prototypes, and they had a resin-based 3D printer. And they would make prototype parts for new printers right there in the shop by printing them. And that struck me as being pretty cool. They had a showcase of all the things it could do and all the parts that it made. And since then I've followed other YouTube channels where they 3D print remote control airplanes and print things for inside of vehicles, and that's a lot different than what most 3D printing is. Most 3D printing is the printing of what I probably shouldn't call trinkets, but they're helmets and masks from TV programs or movies or cartoons or whatever, and then little dust collector things that sit on your desk and whatnot. Well, that's not me. I'm into fabricating things that work. And it turns out that I had plenty of things that I would like to do, and so October 21st I ended up getting this beauty. There we go. It is a QIDI X Max 3. Now if you're not into 3D printing, that won't mean anything. But until a couple of years ago, 3D printing was mostly a hobby unto itself, because the printers that you could buy, frankly, needed a lot of work. And so you needed to learn the science of 3D printing so that you could make improvements to your 3D printer. And so a lot of the things that came off of 3D printers prior to that were just things to fix problems with the printer that you were using. But a couple of years ago, a couple of companies produce a printer that is more like a tool. One of those is Bamboo Labs. They make several printers, and the other one is QIDI. Some people say it Kidi, some people say it Kudi, I don't know. I try to pronounce it Kidi. At any rate, it is a company that produces printers that are mostly functional out of the box. I've had to do nothing to this printer to make it work better. I have printed a few niceties to make my life easier or whatever since October 21st. So I got a few notes here. So I've printed about 15 different things, some of them with multiple parts, and I'll end up showing you some of them. One of them is this little thing to hold tea bags. I used to just cut the top off of a cardboard box and stuff it into the cupboard. But this is much nicer. Let's see. So I've printed a Hughes 500 helicopter body. Actually, I printed all of it, but I just have this piece here to show you. This is a bracket for my Jeep. All of these will probably be future videos, so I'm just going to introduce them. My particular Jeep has the alternator sitting down low on the engine, and the air compressor for the air conditioning sitting up high. Well, as you would have guessed, for a Jeep, a alternator sitting down low is not a good thing. You drive in the rain or the mud or the snow, and that alternator through the air vents eats all that moisture and dirt and grime and whatnot, and it makes them have a terrible life. So there's a couple of companies that make a product that raises the alternator up to where the air conditioner bracket is. Unfortunately, you have to forego an air conditioner in order to use it. And so this bracket is a prototype. Basically, it's to verify that I have the bolt hole locations and distance between the parts properly designed. And so when I raise my alternator up, I'll be able to bolt this to the engine block and verify that I'm using the holes on the timing cover and the holes on the side of the block properly. And then I'll be able to design a bracket that holds the air conditioning compressor. So the air conditioning compressor will be on the bottom, and it has no opening, so it won't care about a little bit of mud, water, or snow. Anyway, that's another thing. I'm putting an Auxbeam 8-gang remote switch in my Jeep, and this is the part that it takes to mount it inside my Jeep. I'm partway through creating a video for that. What else is this stuff in here? Let's see. Oh, I printed something that's actually in the Jeep to mount a tiltometer, so I'll be able to tell the left and right lean of the Jeep. I don't have that to show you. I printed 16 things for my hood scope, for my hood scoop project on the Jeep to hold blind nuts. Compressor bracket, we talked about that. Auxbeam, we talked about that. Hughes. So this little thing here holds the lid open, and you don't have to take it all the way off. For some filaments, the chamber, this is an enclosed chamber machine, but the chamber needs to be open for some filaments, and it needs to be closed up for others. So that little hood prop thing just allows me to prop up the lid. This thing has a USB connection in the back. Well, sometimes I like it to be out front, so I printed a USB clamp and double sticky taped it to the side. Let's see. Okay, now I'm ready to talk about the stuff that's on the back. Some of the filaments, when you print with them, let off toxic gases, and some filaments require an enclosed chamber so that there's no drafts, so the chamber temperature can be raised up. And some filaments require drying before you print because they're hygroscopic. They absorb moisture, and then when it gets heated up to melting temperature, that moisture boils, because most of these filaments print at a temperature higher than the boiling point of water, in the 200 Celsius range. And so those filaments that absorb a lot of water need to be dried out. And so they make filament dryers. And that was one of the first things I knew I was going to print with these more exotic filaments, because I have things that I want to make that require those filaments. the filaments that will withstand under hood temperatures for a Jeep, for example, are hygroscopic, and so I put my printer on wheels. As you know, everything in my shop is on wheels. So this is a dryer for the filament. The filament goes in here, and it gets fed into the printer through this sensor that determines when you're out. And so I printed up this bracket here and bolted it to the back of the printer with 4 longer screws that use screw holes that are already in the printer. And then I also printed up this desiccant holder so that when the dryer is off, this thing will still maintain a low humidity inside my dryer. And for those filaments that let off toxic chemicals, I printed this little vent that bolts on using, again, 4 bolt hole locations that were factory, and I just put in longer screws, and this vents the air out this dryer vent, and then I'll show you how I have it plumbed out the garage door. That's why this thing is actually sitting over here. When I'm printing non-toxic filaments, it actually sits over where the camera is. But in order to print for toxic filaments, the chamber air gets sucked out of the chamber, goes down this tube and along the garage door, and then out what was already existing, which is a cat door. And so these 2 things were some of the first things that I printed. At any rate, I've also had this clock design that I've wanted to build since about 1999, and I was originally going to build it out of wood. Well, now it's not wood, it's 3D printed. And so over here on my drill press, I've got the escapement for the clock, which is the part that regulates the time, set up. So I printed a prototype escapement to verify that my escapement design would actually work. And so, as you can tell, I've been having a good time with my new toy. That's what my wife calls them, is toys. And my friend that is part of the milling machine meeting, named David, he warned me that 3D printing is like a rabbit hole, a very deep rabbit hole. And I'm not really going that deep into the rabbit hole, but I do like its capability, because a lot of things can be made out of plastic, because the plastics are getting really, really good. They have carbon fiber impregnated plastics. They've got fiberglass impregnated plastics. You can buy them that have wood impregnated, so that when you print something, it looks like it's actually made out of a piece of wood. And so in the last couple of years, there have been the growth of what I call exotic filaments that allow you to operate at higher temperatures, provide higher strength. And so instead of just printed parts being relegated to inside the house, they can go and they can be inside of a car body or under the hood, because it will withstand those temperatures. And so that's what really enticed me and drew me over the edge to get a printer now at this point in my fabricating history. I'm still going to make things out of steel and aluminum and turn them on my lathe and cut them on my milling machine, because plastic isn't great for everything, but it does add a capability that I really like. There are some things you can download off the internet and print just straight away. You don't have to do any CAD work. And there are some things that nobody's done before, and you're just going to have to design yourself. Well, if you've got a 3D milling machine, if you've got a CNC milling machine, you're already completely comfortable with CAD systems. And so this is just a different ending to a CAD story, where I used to figure out how to mill out the material that I didn't want, Now I just designed something and it's called additive. So you just add the material that you want. Anyway, that's why I'm here today, is to show you the stuff that I've made. I'm going to disconnect you and show you my vent system. I have printed 2 spools of the toxic material called ASA, and so this comes out of my 3D printer and ends in a connector. Of course, it's hooked, and it ends in this little connector that I printed. And the connector hooks to another piece that's hooked directly to the garage door, and then it runs along the garage door and comes out on the other side of my bandsaw, and then it runs along the garage door some more and goes through the cat door. And so the piece that exits the cat door has a fan on it and a valve. So when I'm not printing, I don't let cold air into the shop. And when I am printing, I just flip the valve, and now the fan can blow directly outside. And so that has been very successful. I've had no smell of ASA in the shop at all. And you know, it took a few hours to print all that many parts, but I'm very happy with it. Okay, I'm back. I got the printer turned back around again. I want to talk to you a little bit about the printer. Like I said, this is a QIDI printer, and the reason I chose this one is twofold. One, it was one of the 2 companies that provides these turnkey printers that don't need a lot of re-engineering or fixing or special techniques to print. QIDI provides a slicer, which is the thing that takes a CAD file and slices it. As you know, 3D printers print in layers, and so it slices it up into thousands of layers. And it has custom settings for each printer, and it has custom settings for each filament. And so when I change filaments, I printed this in ASA because it's going to live outside. It's going to be part of a whirligig for my mailbox. And a lot of 3D printer people have a lot of trouble making their ASA prints either stick to the bed or not crack or not warp. Whereas with the QIDI slicer, I just select QIDI, Rapido, ASA filament, and it sets all the temperatures. So you have the build plate temperature, you've got the chamber temperature, you've got the nozzle temperature, and then you've got 3 fans. One that's on the head that cools the filament coming out of the nozzle, one that blows air across the part, and one that exhausts air outside. It sets all of those fan speeds. And so it really makes it a no-brainer. I just design a part, select the specific filament I want, slice it up, and print it. And 99% of the time, it just prints. I don't have to touch it. I don't have to watch it. I don't have to do anything to it. I did have a problem with this piece. This is actually a piece that failed. You can see it's got a big crack in it. Well, turns out that was my fault, because right about this part in the print, I opened the lid because I was trying to film, and I was trying to invent this little bracket that I made to hold the camera. And I opened the chamber and let cold air from the shop, 50-degree air, into the chamber, which was 55 degrees C. Well, those 2 temperatures are very different, and that caused it to crack. And so that brings me to the second reason I bought QIDI, is because they have outstanding customer support. I wrote to them, sent them my file, and they made a couple of suggestions, but they printed my file right there on their duplicate printer and said, you know, this set of parameters works great for us. And so I knew at that point that I had self-inflicted a wound, which was opening that door. Before, it was I wasn't sure that this printer was going to do that part. So anyway, I went ahead and reprinted it with the same filament, same settings. I just didn't open any of the lid or the door, and it printed perfectly. And so now I've got this big Hughes helicopter. There's two pieces, the front and the back, and some skids and rotors and all kinds of stuff printed up. That'll be another video. One of the other things I did to my printer that I haven't seen done before is I made this door removable. For some filaments, they want you to open the door. Well, in my shop, this door hanging out in the way is just going to get broken. I just know that. So I made it so that it was removable. And now I can remove it, set it out of harm's way, and provide the filament that I'm printing with the air that it needs. And then I can just put the door back on and then close it and store it. So there's been a few things I've done to it to improve it, but none of it was needed to print. It was just convenience items. And so this QIDI customer service is really good. Now, admittedly, this is a Chinese company. I don't know if there are any US made 3D printers, but and so the customer support takes overnight. I write them an email, attach files, videos, print files, all that kind of stuff. And if I didn't leave any pertinent information out, then they will tell me within one cycle of what I did wrong, and help me get it fixed. I have a friend that has another printer like this, and he made a mistake where he printed a filament at too cold of a temperature, and it ended up balling up all around his print head and ruined the print head. And he wrote to them, and even though it was totally his fault, the product was out of warranty, they sent him a brand new print head. And that's the kind of customer service that I need and want, because I just want a tool. It's like buying a hammer. I don't want to have to design the hammer or fix the hammer. I just want a good hammer. And so I'm really pleased with this. Like I said, I've only had it now since October 21st, and I've printed what is probably about 25 parts in 2 different filaments and 2 different colors. And so I'm looking forward to making my clock, finishing my aux beam, my Jeep stuff, and you'll see more of these projects. I try to take a little bit of video with everything that I print. I'm not gonna, bore you to death with minutes and minutes of printing, but I will show you a few stages as it gets built up in the printer. It's kind of interesting to watch, and so I hope this video helps someone. And Merry Christmas from Idaho. See you next time. As usual, if you like or dislike my video, please select the appropriate button and let me know why. I really appreciate comments, and I will answer every one. If you're new to my videos, please select the subscribe and the notification bell to get more videos like this.